And welcome to Technology Tap. I'm Professor J-Rod. In this episode, we're going to talk about post power on self-tests. Let's get into it. All right, and welcome to Technology Tap. If this is the first time that you are listening to me, my name is Professor J-Rod. That's J-R-O-D, like the baseball player. Instead of A-Rod, it's J-Rod. And I am a professor of cyber at New York State College. And in this podcast, what we do is that we talk about all things CompTIA. We talk about the test. I'll do some topics on CompTIA. And, just about anything else that's actually related to computers in general. But we mostly focus on the CompTIA series of exams, A+, Network Plus, Security Plus being the main ones. Every now and then we'll dip into Cloud Plus, CYSA+, maybe penetration testing that I'm planning on taking soon. So welcome if this is the first time that you're listening to me, and I appreciate it. So let's take care of some housekeeping first. So as you guys know, Professor J-Rod wants to change to Dr. J-Rod, and I may need some assistance. If any of you are educational podcasters like me, if you can do me a favor, you can go to my website, professorjrod.com. That's professorjrod.com, and there will be a link for an educational podcast. If you can please do a survey for me. I'm doing a survey on educational podcasting, higher education, college, really using podcasting in higher education, high school and college mainly. So if you're a high school teacher or a professor like me and you using podcasting to enhance your classroom, please fill out my survey. I'm doing my doctoral thesis on educational podcasting. So I would really need your assistance on that. And as always, I appreciate each and every one of my listeners. All right, so let's get into today's topic, post power on self-test. What is power on self-test? Well, it's a diagnostic process that a computer's central processing unit performs when the computer is powered on or restart. The post is part of the system's firmware, typically stored in the computer's BIOS or the UEFI. During post, the CPU and other components are checked to ensure they are functioning properly. So I'm going to give you a general overview of what happens during post. And we're going to start with the CPU. The initialization of the CPU during post involves preparing the central processing unit for operation. This process ensures that the CPU starts in a known state and is ready to execute instructions. Here are the key steps involved in initialization of CPU during post. One of the first things that it does is resets operations. When the computer is powered on or restarted, a reset signal is sent to the CPU. The CPU initializes itself by resetting its internal state to a predefined starting point. It also resets vectors. The CPU fetches a reset vector. A reset vector is a memory address where the initial program counter value is stored. The program counter is a register in the CPU that keeps track of the memory address of the next instructions to be executed. Setting program counter. The CPU sets the program counter with the value fetched from the reset vector. This determines the starting point in memory for the execution of instructions. Initializations of registers. The CPU initializes its general purpose registers to known values. Specific registers may be set to default values or cleared to ensure a clean state. Setting flags. The CPU status flags such as zero flag, carry flag, and overflow flags are typically set to default values. These flags are used to indicate the outcome of algorithmic and logical operations. Mode settings. Depending on the CPU architecture, the processor may operate in different modes. For example, real mode or protected mode. The CPU sets its mode to an initial state, determining how it interacts with memory and other system components. Self-diagnostics and system checks. The CPU may perform self-tests and diagnostic checks during the initialization to ensure the internal components are functioning correctly. Any errors detected during these checks may result in error messages or diagnostic codes. By the end of the CPU initialization process, the processor is in a state where it can start executing instructions from the system firmware or the bootloader. The overall goal is to establish a reliable and consistent starting point for the CPU's operation, ensuring that subsequent instructions are executed correctly as part of the boot up sequence. Memory tests. The post checks the system's RAM, random access memory, to ensure that it's functioning correctly. This usually involves writing and reading data to and from different memory locations. The memory test is a crucial component of the power on self-test performed by the computer during the boot up process. The purpose of the memory test is to check integrity of the system's RAM. And remember, RAM is volatile memory and that stores data and machine code currently being used and accessed by the computer's processor. Here's an overview of the memory test when it's typically conducted during post. Memory address check. The post starts by testing different memory addresses to ensure that the RAM is accessible. It writes specific patterns of data to different memory locations and then reads the data back to verify correctness. Data bus test. The data bus is the communication pathway between the CPU and the RAM. The memory test checks the data bus by writing data to the RAM and then reading it back to ensure that the data is transferred correctly. Address bus test. The address bus is responsible for specifying a memory address. The post tests the address bus by verifying that the CPU can correctly address different locations in RAM. Pattern test. The memory tests often use specific patterns such as all zeros or ones or alternating patterns to write and read from the memory. This helps identify issues with specific bits or cells in the memory. Walking bit test. This test involves writing a specific bit pattern to memory and then shifting the bit pattern to the next memory location. It helps detect stuck or faulty bits in memory. Checkerboard test. The checkerboard test alternates between writing patterns to odd and even memory address. It helps identify issues with adjacent memory locations. March test. March test involves a sequence of read and write operations that transfers through the memory. Tests like March C and March B are variations designed to detect different types of memory faults. Bit flip test. Bit flip test intentionally flips individual bits in memory to check if the memory can correctly store and retrieve data. Memory size detection. The post may also detect and verify the amount of installed RAM to ensure that the system recognizes the correct memory state. If any errors are detected during the memory test, the post typically generates error messages or beep codes, providing information about the nature and location of the memory issues. Users or technicians can then use this information to diagnose and address the hardware problems. A successful memory test is crucial for ensuring the stability and the reliability of the computer systems, as faulty RAM can lead to a variety of issues, including system crashes, data corruptions, and unpredictable behavior. Next, we're going to do power supply checks. Power supply checks are an essential part of power on self-test and the overall system diagnostics. A stable and reliable power supply is crucial for proper functioning of a computer system. Here are some common power supply checks performed during post. Voltage rails monitoring. The power supply provides different voltage levels, commonly 12 volt, 5 volt, 3.3 volt, to various components on the system. The post may check the voltage on these rails to ensure that they are within Acceptable tolerance levels. Deviation from the specific voltage level can indicate power supply issues. Power goods signal. The power supply generates a power goods signal to indicate that all power rails are stable and within the specific voltage range. The system waits for the signal before proceeding with the boot process. If the power goods signal is not received, the system may halt to prevent potential damage. Overvoltage and undervoltage protection. The power supply may have built-in protection the power supply may have built-in protection mechanism to prevent overvoltage or undervoltage situations. The post checks for any overvoltage or undervoltage conditions and takes appropriate actions to safeguard the components. Short circuit protection. Power supply often short circuit protection to prevent damage in the event of a short circuit in the system. The post may check for short circuits and respond accordingly. Power supply fan check. The post may check whether the fan in the power supply is operational. A malfunctioning fan can lead to overheating, and the system may halt or generate warnings if the fan is not working properly. Power on delay. Some systems incorporate a power on delay to ensure that the property supply stabilizes before components start operating. This delay helps prevent issues that could arise from unstable power supply during the initial moments of powering on. Load test. The post may perform load tests to check how well the power supply handles varying loads. Fluctuation in power demand, such as during the startup of components, should be handled smoothly by the power supply. Power factor correction check. Some power supplies include PFC or power factor correction to improve the efficiency of power usage. The post may check whether the PFC is functioning properly. If any issues are detected during the power supply checks, the post may generate error messages, beep codes, or other indicators to alert users or technicians about potential problems. Addressing power supply issues is crucial to ensure the system's stability and to prevent damage to other components. If you suspect power supply problems, it is recommended to consult the system documentation or seek assistance from a technician support or a qualified technician. In other words, just throw it away. Do not try to fix a power supply. It's a $30 part that any company will have a spare. Anything wrong with the power supply, do not attempt to open it. Just throw it out. It's a $30 part, ladies and gentlemen. Next, we're going to do initialization of input-output devices, which is a crucial step in post process. I/O devices include peripherals such as keyboards, mice, storage devices, and other external devices connected to the computer. The initiation of these devices ensure that they are recognized and operational. Here is an overview. Enumerating devices. The system's BIOS or UEFI begins by enumerating and identifying the I/O devices connected to the system. This process involves identifying the type and location of each device. Initializing system buses. The system buses, PCI, PCIe, that connect to the CPU to various I/O devices are initialized. This involves configuring the bus and ensuring proper communication between the CPU and the connected devices. Assigning resources. The bus or the UEFI assigns system resources such as IRQs, which are interrupt requests, I/O addresses, and memory address to each I/O device. The allocations ensures that devices can operate without conflicting with each other. Testing I/O device. The post performs basic tests on each I/O device to ensure they are functional. For example, the system may check whether a keyboard and a mouse respond to input or if a storage device can be accessed. Loading device drivers. The system firmware may load basic device drivers for essential I/O device, enabling communications between the operating system and these devices. This is often a preliminary step to ensure that the critical devices can be accessed during the boot process, right? Because as soon as you turn it on, it's not loading right away to the operating system, right? It's doing post and BIOS. But what if you need to get into the BIOS or the CMOS, right, before it goes to the operating system? So it has to load these drivers, minimal as they may be, in order for you to see the screen, to use the keyboard. For example, if UEFI, is the ability to use the mouse, and sometimes network access. Detecting bootable devices is next. The system identifies and prioritizes bootable devices such as hard drives, solid-state drives, and optical drives. The BIOS or UEFI determines the device from which the operating system will be loaded. Initializing mass storage devices. Mass storage devices such as hard drive or SSD undergo initialization checks to ensure they are responsive and accessible. The system may check for the presence of valid boot records on these devices. Initializing display devices. Display devices such as graphic cards and monitors are initialized to enable video output. The system sets display resolutions and refresh rates based on the capabilities of the connected monitor. Loading expansion card firmware. If there are expansion cards in the system, for example, graphic cards or network cards, their firmware may be loaded and initialized. This ensures that additional functionality provided by these cards is available to the system. Network initialization. If the system has integrated or add-on network interfaces, the firmware may initialize these interfaces. This enables network communications and may involve obtaining an IP address through DHCP, Dynamic Host Configuration Protocol. If any issues are detected during initialization of I/O devices, the post may generate errors, beep codes, or display information to indicate the nature of the problem. Proper initialization of the I/O device is essential for the successful booting of the operating system and overall functionality of the computer system. BIOS integrity check is a critical step in post. It processes during the computer's boot up sequence. The BIOS is firmware that resides on a chip on the motherboard, and it provides low-level control for the hardware components of the computer. Ensuring the integrity of BIOS is critical for the system stability and proper functioning. And let's do an overview. First, we're going to start with read-only memory check. The BIOS is typically stored in non-volatile memory chip, often referred to as ROM, read-only memory or flash memory. During the post, the system checks the integrity of the BIOS stored in RAM. This involves reading the BIOS code from the memory and verifying its integrity. Checksum verification. The BIOS code is often accomplished by a checksum or hash value, which is a mathematical sum calculated based on the contents of the BIOS. The post performs a checksum verification to ensure that the calculated checksum matches the expected value. If the checksum does not match, it is suggested that the BIOS code may be corrupted or modified. Digital signature check. Some modern systems may use digital signature to verify the authenticity and integrity of the BIOS code. A digital signature is a cryptographic mechanism that ensures the code has not been tampered with. The BIOS may contain a digital signature, and the post checks its validity. Boot BIOS integrity check. The BIOS typically has a small portion known as boot block that is responsible for essential functions, including the initial stages of the boot process. The integrity of the boot block is checked to ensure that critical functions, such as reading from storage devices, are intact. Error handling. If any issues are detected during BIOS integrity check, the post may generate error messages, beep codes, or display information indicating a problem. Error messages may provide details about the nature of the issue, such as checksum mismatch or corrupted BIOS. BIOS recovery, if is available. Some systems are equipped with BIOS recovery mechanism that can be activated if the primary BIOS is found to be corrupt. In the event of a BIOS integrity failure, the system may attempt to recover using a backup copy of BIOS or initiate a process to reflash the BIOS. Ensuring the integrity of the BIOS is critical because the BIOS plays a fundamental role in the early stages of the boot process. If the BIOS is compromised or corrupted, it can lead to system instability, failures, or the inability to boot the operating system. Manufacturers often provide tools and procedures for updating or recovering BIOS in case of issues, emphasizing the importance of maintaining BIOS integrity. Expansion cards are part of the post process that occurs during the computer's boot up sequence. The post verifies the presence of functionality of these cards to ensure their proper system's operation. Here is an overview of expansion cards checks. Presence detection. The post checks for the presence of expansion cards in their respective slots on the motherboard. It detects the type and the number of expansion cards installed. It is initialization of integrated circuits. Each expansion card contains integrated circuits responsible for specific functions. The post initializes these ICs to ensure they are ready for operation. Testing for basic functionality. The post performs basic tests to ensure that each expansion card is functioning correctly. For example, a graphic card may be tested for video output, a network card for network connectivity, or a sound card for audio output. Address assignments. The system assigns address, interrupts, and other resources to each expansion card to prevent conflicts. The post ensures that these assignments are made correctly and do not overlap with other devices. RRQ or interrupt request handling. Expansion cards often use interrupts to communicate with the CPU. The post checks the RRQ settings for each expansion card to prevent conflicts and ensure proper communication. And you are so lucky nowadays, guys, that you do not have to deal with RRQs. Back in the day, you had to, and let me tell you something, it was not pretty at all. Very complicated, especially with modems and sound cards when they first came out. Expansion ROM initialization. Some expansion cards have built-in firmware or expansion ROMs that provide additional functionality. The post initializes the expansion ROMs to make sure they're accessible and operational. Error detecting and reporting. If any issues are detected during expansion card checks, the post may generate error messages, beep codes, or display diagnostic information. Error messages help identify the specific expansion card causing the problem. Graphic card initialization. The initialization of a graphic card is a crucial part of the expansion card checks. The post ensures that the graphic card is operational and capable of providing video output to the display. Bootable device identification. Some expansion cards, such as storage controllers, may be responsible for connecting to a bootable device, for example, a hard drive. The post identifies and verifies the presence of these bootable devices. Network interface initialization. If a network card is present, the post initializes it to enable network connectivity. And like I said before, it also involves obtaining an IP address through DHCP. These expansion card checks are important for ensuring that all components of the system are properly detected and initialized during the boot up process. Any issues identified during this phase can be critical for diagnosing and resolving hardware-related problems. If there are problems with specific expansion cards, user may need to reset or replace the cards, update firmware or drivers, or address any conflicts in an expansion configuration. Next, we're going to talk about the graphics card because that's very important. The graphic card display test is a critical component of post during the computer's boot up sequence. The test focuses on verifying the functionality of the display subset, which includes the graphic card, monitor, and related components. The primary goal is to ensure that the system can provide video output to the display, and the display is capable of presenting information for the user. Here's an overview. Graphic card initialization. The post begins by initializing the graphic card, which is responsible for rendering image and showing them to the display and sending them to the display. This involves configuring the graphic card and ensuring that it's operational. Checking video memory. The post may perform a quick test of the video memory on the graphic card to ensure that it's functioning correctly. Any issues with video memory can lead to graphical artifacts or display issues. Setting display parameters. The system configures display parameters such as screen resolution and refresh rate based on default settings or user-defined preference stored in BIOS or UEFI. Output to display. The post sends a signal to the display, instructing it to show specific patterns or information. This allows the system to verify that the display is receiving signals and present information. Color and pixel test. The display may show a series of colors, patterns, or pixel grids to ensure that each pixel on the screen is functional. This helps identify any dead pixels or abnormalities in the display. Testing multiple monitors if applicable. That's 2 or more monitors. And if you're not doing that, you're not living. System with multiple monitors may undergo tests to ensure that all connected devices are functioning as expected. This includes checking for corrective detection and configuration of multiple display outputs. User interface elements. Some systems display basic user interface elements during posts, such as the manufacturer's logo, system information, or diagnostic messages. This provides visual feedback to the user and indicates that the display subsystem is operational. Error messages on beep codes. If any issues are detected during the display test, the post may generate error messages, beep codes, or other visual indicators to alert the user. These indicators help diagnose problems with graphic cards, monitor, or display connections. External display checks. For systems with external display connectors, HDMI, or display port, the post may check the functionality of these connectors and the corresponding signals. The display test is crucial because it confirms that the computer can communicate with the display hardware, providing a visual interface for the user. If issues are identified during the test, users may need to check the display connectors, test with a different monitor or a different cable. They could also troubleshoot problems with the graphic cards or its drivers. The visual feedback provided during the display test is valuable for diagnosing and resolving potential display-related issues. Storage device checks have an integral part of posts. These checks are designed to verify the presence, integrity, and functionality of storage devices, such as hard drives, solid-state drives, and other storage peripherals. First is we're going to go over detecting attached storage devices. The post begins by detecting and identifying the storage devices connected to the system. This includes internal drives, external drives, and other storage peripherals. Initialization of storage controllers. The storage controllers can manage data transfer between the storage devices, and the rest of the systems are initialized. This involves checking the integrity of the controller and ensuring that it's ready to communicate with attached storage devices. Checking storage device power and connection. The post verifies that the power supply and the data connected to the storage devices are stable and correctly configured. Loose cables or power issues can lead to storage device failures. SMART. Self-monitoring analysis and reporting checks. If supported by the storage device, the post may query SMART data to assess the health of the drives. SMART checks can identify potential issues with the drive, such as bad sectors or intermittent drive failure, so that you can back up. BIOS UEFI recognition. The post ensures that the system BIOS or the UEFI recognizes the storage device. The BIOS UEFI provides information about the connected drives and their basic configurations. Boot sector and partition checks. The post checks the boot sector and the partition information of bootable drives to ensure they are correctly configured. If the system is configured to boot from a specific drive, the post verifies that the drive contains a valid bootloader. Read and write tests. Basic read and write tests may be performed on the storage device to ensure that the data can be properly written to and read from the devices. These tests help identify issues with data integrity and storage device performance. RAID configuration checks. If applicable, in a system with a RAID, which is redundant array of independent disk configurations, the post verifies the status and the integrity of the RAID arrays. This includes checking for failed drives and ensuring that the RAID's configuration is consistent. Error handling. If any issues are detected during the storage device checks, the post may generate errors, beep codes, or display diagnostic information. These indicators help identify the nature of the storage-related problems. Loading storage device drivers if needed. If specific storage devices are required for proper operations, the post may load these drivers to enable communications between the operating system and the storage device. Ensuring the proper functionality of the storage device is critical for the successful booting of the operating system and overall system stability. If storage devices are identified during post, users may need to check cables, replace faulty drives, update firmware, or address configuration problems to ensure reliable storage performance. If issues are detected during post, the system may display Error messages, beep codes indicate the nature of the problem. These codes can help technicians diagnose and troubleshoot hardware issues. Now, we know that if we have issues with post, right, there's this thing called a postcard. I honestly have never worked with a postcard, but I'm under the assumption that if you work for a company like Dell and all you're doing all day is fixing motherboards, that you will be familiar with postcards. But postcards, if you don't get any beep codes, right, and anything that displays on the monitor, right, you can use this card, and that card will give you an error number, and then you look up what that error number means. Kind of like when when you take your car to the mechanic, and they run that test for error codes. Post does the same thing for PCs, so it does the same thing as you would for your car. All right, that's going to be it for Post. Again, ladies and gentlemen, if you are a creator of educational podcasts, kind of like I am, right? This is considered educational podcast. If you can go on my website, Professor J-Rod, that's J-R-O-D, and you will see a tab on there that would say for research survey, and then you click on that, and then you will see the survey. Please only click on it if you are an educational podcaster in higher education, high school and college. You'll be doing me a great favor as I'm doing my doctoral research, my thesis on educational podcasts. So I would appreciate if you guys can help me with that. And as always, thank you. All right, that's going to be all for today. Thank you very much for listening. And this is Professor J-Rod signing off. This has been production of Little Cha-Cha Productions, art by Sarah, music by Joe Kim. If you want to reach me, you can email me at Professor J-Rod, that's J-R-O-D @gmail.com. I'm also on TikTok, Professor J-Rod, and on Instagram, Professor J-Rod.